Before the mathematical thriller begins, flow into gratitude for this mathematical thriller. Flow into gratitude for every prime number that has ever existed, for every curve that calculus has ever measured, for every hidden pattern buried inside the integers, for every infinite series that never truly ends, for every dimension geometry has ever imagined, for every unknown that mathematics still refuses to surrender. Now, a single particle is placed at the origin. The journey begins with a number, not with motion, not with distance, with a number. Every step of the journey is controlled entirely by the hidden mathematical structure of that number. First, every prime factor inside the number is counted, including repeated ones. That count is transformed into a probability using factorials, trigonometric functions, exponential decay, and normalization. That probability decides the particle's next rotation. The angle of that rotation is not fixed. It is constructed from the golden ratio, the number of divisors, the number of distinct prime factors, and pi. Before the particle even moves, probability, number theory, irrational constants, and geometry have already become one system. Now the particle accelerates. Its velocity is no longer a simple quantity. It evolves through a differential equation whose driving force is an integral continuously changing with time. At the same instant, the equation is simultaneously altered by the Mobius function from number theory. Continuous calculus and discrete arithmetic are now controlling exactly the same motion. The particle finally travels, but even its distance cannot escape higher mathematics. Every length is calculated through a hypergeometric function and immediately reshaped by every prime dividing the current number. Distance itself has become a number-theoretic object. Then the universe changes. The instant the particle crosses a geometric boundary, ordinary reflection disappears. Its position is transformed repeatedly through a complex quadratic mapping until the trajectory settles on the boundary of a Julia set. The path is no longer merely moving. It is entering a fractal whose boundary contains infinite detail at every possible scale. Meanwhile, the particle's mass never remains constant. It grows through continuous compounding. Its growth rate is itself generated by an infinite trigonometric series. Every moment influences every future moment without ever repeating exactly. Then the space beneath the particle bends. Flat geometry vanishes. Distance is redefined by a metric tensor. Straight lines cease to exist.
The particle is now forced to follow geodesics through curved space. The number governing the current step is examined again. If it can be written as the sum of two perfect squares, the traveled distance is immediately rewritten using divisor sums, Euler's totient function, and logarithms. Arithmetic has reached forward and altered geometry itself. Now every step taken since the beginning is collected together. An infinite alternating series is formed. An infinite product is constructed. An infinite average is computed. Three independent infinite structures emerge from one single trajectory. But not every trajectory survives. Every bend, every twist, every curvature accumulated throughout infinite time is squared, integrated, and forced to equal one precise mathematical constant. Every path, failing that condition, is eliminated. Only the surviving trajectories remain. And only then does the true mathematical thriller begin. Determine the particle's exact final position after infinitely many steps. Determine the complete uncertainty of that final position. Determine the Hausdorff dimension of the limiting trajectory. Determine whether the motion converges or wanders forever. Determine whether the path intersects itself infinitely many times. Determine the exact value of the infinite series, the infinite product, and the infinite average generated by the journey. Determine the total geodesic curvature accumulated over infinite time. Determine the asymptotic spectral radius of the transition operator. Determine whether the entire stochastic process is ergodic, mixing, and reversible. And finally, either produce one exact symbolic expression containing only mathematical constants and special functions, or prove that no such closed-form expression can ever exist.